So when you want to do something new, something big, that doesn't yet exist, first of all, you need time, you have to be patient, and you need to have a good plan to build it. If you don't have any plan, it's wise to start to elaborate a plan before to start the construction process. And it is what is about architecture and design. And considering the high level of complexity of decision support systems, these two terms, architecture and design, are quite essential. So, structure of my talk. First, I will briefly present what is architecture, basically, and what is design, and why you should care about these two terms. They are quite important regarding DSS, what are the challenges, and then what could be the main focuses for the community of practice. Architecture. Basically, the architecture helps to get the big pictures of a system, to understand this system, how it works. It could be a DSS, but it could be also a car motors. So basic idea is to know about the system's components. What are the system components? How they behave within the system? What is the role? What is the function of these components? And what are the interaction among all these components? Difficulties to hear me? Is that better? Like, oh yes, it seems to be better. So, should I restart, or have you understand what I said? Good. So, architecture. Then the design of an IT solution. It's quite similar to the elaboration of an architectural plan. An architect, we want to build big building, has first to elaborate a plan. Most of the times, it's not just one single plan. It's too complex to reduce the construction of a building on a single plan. So he will elaborate many plans, different level of details, from different perspective, and plans that are meant for different type of actors. And he will involve steadily the customers in order to be sure that the plan that he is elaborating fit to the need of the customers. So it's quite similar to develop an IT solution. It's important to have a methodology, to know how to proceed step by step, to know also which kind of modeling techniques you will use. And for that, we have software engineering. Software engineering provides such kind of methodologies. I will not go in details, but it's interesting to look at the different phases of the development process. You have the user requirement, you have system specification, software design, and then implementation, testing, and maintenance. So, why should you care about it, about architecture and design? First of all, as a user, to become kind of power user, if you have the big picture, if you really have background understanding, then you will be able to use the system at its best. And if you also know pretty well what is architecture and design, you will be also able to influence the development process of a DSS according to your needs. And from the point of view of a researcher, mainly is to ensure the knowledge sharing and knowledge transfer, to build a tool, a management tool that is useful for practitioners, for example. But it's also to take advantage of existing components, platforms that have already been developed by other members of the DSS community. And as an IT specialist, it's important to share common understanding in a specific domain with users and researchers. And it's also interesting to make sense of ICT technologies in this very domain. So now the challenges. Basically, the main challenge when we develop a DSS is to develop a tool that is useful, and that means that will be used by users. And considering this, Rogers elaborated an interesting theory, diffusion innovation theory, and he defined 5 key ingredients that should be taken into account when you develop an IT solution in order that it will be used after the development process. So first aspect to take into account, that is a relative advantage to the current situation. The user should have this relative advantage. It should be useful, and something more than what is currently available. And then it should be compatible to the current structure of the users. The level of complexity should not be too high, considering this relative advantage. It means the solution should be as simple as possible. And it's important that the user can experience the solution before he purchases or decides to install it in his system. And the degree of observability of the technique is also important. That means it's important to benefit from others' experiences in order to know what will be the implication of installing this new solution in a system. So when we look at DSS, here we have the basic structure that we see, the data, the models, the algorithm, the user interface, and the user itself. So it's important to know about the relative advantage. If it is embedded, it could be embedded in the work system of the user. If the user interface is intuitive, simple to use. If the user understands what happened within the system, should avoid black box. Then the level of complexity should be adapted to the decision situation. The level of complexity of the models should also be adapted to the available data. Good. Difficult, we see. And then it's important to develop a system which works with data that users have or are likely to have. And another major aspect is interoperability. Not the idea that you build a system of its own, but that it is compatible with other systems. So, based on that, here we have a first attempt for focuses for the community of practice. A major aspect is the decision itself, the decision context, and especially the approaches, methodologies to grasp, understand, and design complex systems. So it will be nice to have an overview of such kind of methodologies. The decision makers and the stakeholders are of great importance. They will use the DSS. The question is how to get them involved actively in the development process from the beginning, and how to promote a shared understanding with them. Then another major aspect is how the technological possibilities. Considering now the technologies is evolving very fast. We have smartphones, there is Google Glass coming soon. So many new ways to interact with the user. What are the implications for it's interesting to think about the implication for DSS development. It's also possible nowadays to interconnect data, models, functionalities across platforms. So to have kind of meta DSS. When you have the plan of your DSS, the first step is to develop a prototype. And here, for that, you need developer skills, IT skills. So the question is which kind of development platform you want to use. If you want to develop in an open source environment, so here we could be to provide some guidelines for researchers who want to develop such kind of prototypes. And then a difficult step is a step from the prototype to the product. To the product, we have to care about software quality, reliability, reuse, care about licensing, user support, maintenance, further developments, and also about the user community. this aspect we will speak about later this afternoon during the work plans of the community of practice. Okay, other questions?